Hello everyone, welcome back to June Studyla channel. Let's continue with our lesson for IGCSE Chemistry, Chapter 3, Part 3, Elements and Compounds. Before further ado, let's look into our study outline for Part 3. Our study outline for Part 3 consists of single covalent bond for methane molecule, single covalent bond for water molecule, single covalent bond for ammonia molecule, single covalent bond for hydrogen chloride molecule, double complex covalent bond for oxygen molecule, double complex covalent bond for carbon dioxide molecule, differences between ionic and simple covalent compound, giant covalent structure, and finally differences between diamond and graphite properties. Covalent bond or single bond for methane molecule. Formula for methane is CH4, so 4 hydrogen atom and 1 carbon atom, whereby carbon atom has the electronic configuration of 2.4. Carbon is actually group 40 of the periodic table and which has 4 electrons in its outer shell, and it requires 4 more electrons to form the octet configuration. So each carbon atom share electron with 4 hydrogen atoms, and the carbon atom will attain the octet configuration. So on the other hand, each hydrogen atom will attain duplex configuration. So in other words, for methane molecule, each hydrogen share 2 electrons with carbon. Let's look into water molecule. Formula for water is H2O. So when 2 atoms of hydrogen and 1 atom of oxygen get close together, they share the electrons in their outer shell. So as you know that oxygen atom consists of electronic configuration of 2 oxides. And in each molecule, oxygen atoms share electrons with 2 hydrogen atoms, and whereas oxygen atom have 8 electrons in its outer shell, and whereby hydrogen atom have 2 electrons in its outer shell. And for the water molecule, hydrogen and oxygen both have to fill their outer shells by sharing electron. Let's look into ammonia molecule for the covalent bond or single bond. Formula for ammonia is NH3, where we have 3 hydrogen atoms work closely with 1 nitrogen atom. And nitrogen atom, their electronic configuration is 2.5. As you know already, nitrogen is in group 15 of the periodic table, and it has 5 electrons in their outer shell. And in order for nitrogen to achieve the octet electron, so each nitrogen needs another 3 electrons. So when 1 nitrogen atom works together with 3 hydrogen atoms, they share their valence electron. So each nitrogen atom share electron with 3 hydrogen atoms. Each hydrogen atom have duplex configuration, and on the other hand, nitrogen atom have the octet configuration. So ammonia molecule is the hydrogen and nitrogen both fill their outer shells by sharing the electron. Let's look into the hydrogen chloride molecule. Formula for hydrogen chloride is HCl, 1 hydrogen atom and 1 chlorine atom. And chlorine atom, as you already learned, the electronic configuration is 2.8.7. When 1 atom of hydrogen and 1 atom of chlorine get close together, they share the electrons in their outer shell. So in each molecule, hydrogen atom share electron with 1 chlorine atom, and chlorine atom have 8 electrons in its outer shell, and On the other hand, hydrogen atom have one electron in its outer shell. So hydrogen chloride molecule is actually hydrogen and chlorine both fill their outer shell by sharing electron. Let's look into more complex covalent bond, or it's used to call as a double bond. For the oxygen, formula for the oxygen is O2, and each molecule contains two oxygen atoms. And as you already learned the periodic table, oxygen is group 16, and in addition it has 6 electrons in its outer shell. And to become octet configuration, oxygen needs to have 2 extra electrons. So when two oxygen atoms comes together, they share 4 of their outer shell electrons. So the oxygen atom share 2 pairs of electrons. So this is called double bond or double covalent bond. And another example of more complex covalent bond is carbon dioxide molecule. Formula for carbon dioxide molecule is CO2, which is one carbon atom and two oxygen atom. And carbon, as you already learned, is come from a group 14 of the periodic table, where it has 4 electrons in its outer shell. And to become the octet of electron, each carbon needs another 4 electrons. So when two oxygen and one carbon atom come together, they share their electrons. So the carbon atom and each of oxygen atom have 8 electrons in their outermost shell. So by doing this, they already achieve the octet stability. This is the diagram show the differences between the ionic compound and the simple covalent compound properties. So let's look one by one. So in terms of the volatility, solubility, and the electrical conductivity. So for the ionic compound, volatility, ionic compound is not volatile and it's have high boiling points and high melting point. And in terms of the solubility, most ionic compound soluble in water, insoluble in organic solvent like cyclohexane. And finally, electrical conductivity, the ionic compound does not conduct when in solid state. And when molten or dissolved in water, they do conduct. On the other hand, let's look into the simple covalent compound in terms of the volatility, solubility, and electrical conductivity. For the simple covalent compound, many are volatile and have low boiling point and low melting point, and most are soluble in water and soluble in organic solvent. And finally, the simple covalent compound do not conduct in solid or liquid state or in aqueous solution. Let's look into the giant covalent structure. In this scenario, we put up the diamond and graphite for the giant covalent structure. So the giant covalent structure is so-called macromolecular structures, where the structures with a network of bond which repeat throughout the whole structure. Diamond and graphite are both giant covalent structures, which is made of carbon atom. And in diamond, each carbon atom will form 4 covalent bonds with each carbon atom. And this network of strong bond extend unbroken throughout the whole structure. Whereas in graphite, the carbon atoms are hexagon, arranged in layer, and they have high melting and boiling point. It is very difficult to break down the network of the strong covalent bond. Both diamond and graphite needs high temperature to overcome the huge number of strong bonds and melt the solid. And both of them are insoluble in water and in organic solvent. The network of covalent bond is too strong to allow solvent molecules to form strong enough bond with the carbon atom. Let's look into the differences between the diamond and graphite properties in terms of the hardness and electrical conductivity. For the diamond, in terms of the structure or the properties is very hard. Strong network covalent bond make it difficult to scratch the surface of the crystal. And diamonds is used for the edge of tool such as glass cutter and drill bits. And in terms of the electrical conductivity, diamond does not conduct electricity. It is a covalent compound with no ions. None of the electron is free to move along the structure because they are all involved in bonding. On the other hand, graphite is very soft. It is easy to scratch. The forces between the layer of graphite are weak. The slide can slide over each other when force is applied, and the layer flip away easily, and it is used as a lubricant and in the lid of pencil. And in terms of the electricity conductivity, graphite conducts electricity. Three of the electrons in each carbon atom are used to form covalent bonds, and the fourth electron in each atom is free to move around and along the layer. These are called delocalized electron or mobile electron. When voltage is applied, the delocalized electron can move along the layers. With that being said, I would like to wish you all the best in your study and hope you are clear with the presentation of the subject matters. You can get the detailed or customized notes by clicking Jom Study Lab Instagram. And last but not least, please press the thumbs up like button, subscribe to free lectures Jom Study Lab YouTube channel, and follow me at Jom Study Lab Instagram. Thank you very much.